Okay, so today we're going to go over Swift. It's a fairly new programming language. As you may know, Swift is a general purpose compiled programming language that's only been out for about a month. This is July, so it was introduced last month by Apple. You may know a little bit about Apple hardware. Apple is a company that prizes in-house development, so they don't make a lot of things very open for other people to use. One thing that they've done is develop their own programming language for both iOS, such as iPhone and iPad, but also for the Mac itself, their OS X operating system. And that has been Objective-C, which for many people have been a really big barrier to learning how to program Macintoshes as well as iPhones and iPads. So this last month they introduced this new programming language, which is to try to bridge that gap. But after investigating it for a while, it seems that this is really a general purpose programming language that puts together a lot of different types of things that you find in other high-level languages and other types of programming paradigms, especially the functional programming paradigm, which you will probably learn about later in software engineering and programming language classes here at NUS. So unfortunately, Apple has not made this language really public yet. You know, they've announced it. It's in beta, but it means that anyone who wants to try it actually needs to have a developer account to actually build things on the iOS or Mac using Swift. However, you can find copies of Xcode, and if you have the Xcode 6 beta, then you can play around with it. So that's what we're going to do today, and basically that's what we want to do. So there are some important Swift facts. Let's just try to look at this. So Swift is supposed to be not a replacement, but a simplified language to work alongside Objective-C, which is, again, Apple's core language, and it's taken some features from other programming languages, like I said, and also taken away some features that are in Objective-C. So noticeably, pointers, which are horrifically difficult for beginners to learn, even in normal programming languages like C, have been removed. So we don't have pointers in Swift. We rely on the virtual machine in the hardware, the software, to emulate dealing with memory allocation and deallocation, so we don't have to worry about the low-level things. But that also means we lose a little bit of power. But for most people, that's not going to make much of a difference because it means that the machine will be doing the optimization for you. Okay, anyways, there's a lot of interesting things about this. I'll just quickly show you part of the keynote that is there.
Development that you've never seen on the platform. When it comes to speed, Swift is great. Compare Python, a popular scripting language, with Objective-C when it comes to something like, let's say, complex object sort. Objective-C is a lot faster, but Swift is faster still. And take something like RC4 encryption, extremely computationally intensive. Python gets utterly crushed in this particular benchmark. But look at Swift. Now, Swift is also modern with features like closures, generics, type inference, multiple return types, and namespaces.
So those are all the Apple fans there. Okay. But importantly is to think about what they are talking about. Let me see, where did the window go anyways? Okay. What happened in Swift? Well, a lot of different things. Basically, they took compiled languages that run fast, interpreted languages like Ruby and Python, which you all know, right? You can open up an idle window or a Python interpreter, and you can see things happen as soon as you type them. That's not true of C or, for the most part, Java, right? So they've introduced that in Swift. They've also introduced some other functionality for closures and other things of that sort. So I'll show you what that means, but we'll get a a taste of that later. Okay, so I'm going to skip this part. I think all of you have done this part already, to download and install Xcode 6 beta. But if you don't, and you don't have access to a Macintosh, you probably need it to really run Swift until somebody gets around to building a cross-compiler, which I'm sure someone's already working on for Linux and Windows. Okay, so one thing that's really useful about Swift is it has this interpreter-like ability to do things, right? So Python, you know, is interpreted, right? You don't compile it, you just run the Python program and you pass it the source code and it actually executes your source. Well, Swift is not like that. It's actually compiled. It's compiled into a virtual machine language, just like Java is, right? Java is compiled into something that the Java virtual machine can interpret for you. And so that's what happens for Swift. Okay, so there's this acronym called read, eval, print, loop, which is what all interpreted languages do, and that's something that Xcode does inside of Swift. Okay, so we'll run Xcode here. Let's go to the beta app. Okay, let's shrink this out of the way, and we're going to open up a document here. Let's see. So we're going to go to the document and API reference over here. Okay, when you start Xcode, you can come to that. Okay, and you'll see that it starts with search documentation, but you know all of the information is already here. A Swift tour. So we're going to go to this part of the document. Okay, and here's the actual book that Apple distributes. You can find this on the web. They have it as a free download. Of course, you have to download it into iBooks, which is Apple's proprietary software, etc. But anyways, the important thing about this is it's a tutorial, but you can make it interactive by opening it up in Xcode, which is Apple's IDE, an integrated development environment. So we're going to do that, and hopefully it didn't crash. Okay, where did it go? Okay. I don't know where it went. Okay. Let's see what we can do it. Okay, so now we have what they call a playground open. All right, this is basically documentation interleaved with something like an interpreter. All right, so you can type lines of code directly into this. Like you can say, I want a variable. I'm going to call it hello, and I'm going to give it maybe a string, ni hao. Okay, and then execute that, run it. And then after a while, you know, the interpreter, the compiler will print it out. So you can see it's actually running the code that's visible there. Now, of course, you're looking at these two statements, right? Print line, hello world, and it's saying, gosh, where did that go, right? It's not here. So it actually appears in the console window, but it's not actually shown here. So you have to open up a secondary editor to see this. There's an assistant editor under Navigate. And if you open that up, and because we don't have very much screen space, this is going to get very squeezy, okay, you'll see that on one of the sides here. I don't know which side it's going to come up on. Okay, so. Okay, well, I'm not sure where it went, but if you open up the assistant window, it should be there. Let's see. Okay. Okay, so that's how you get started with Swift. You can go through this tutorial. It's quite comprehensive. You can see the scroll bar is pretty long here. So I don't want to go through the whole tutorial. Rather yet, I want to go through another tutorial which compresses it a bit, because you guys all know Python already, right? So it makes it very easy to get started. Okay, so I'm going to close this and go back to the Google document. Okay. So we're going to walk through one of the tutorials that's on the web. You can open it up now. Okay, and I have to get out of full screen mode for that. because I'm going to try to put these two on the same page and hope that it fits. Okay. Can you still read the text up there in this small font? Not really. Okay, let me make it a little bit bigger. How's that? Okay. Okay, and we're going to put the Xcode stuff on the other side over here. Okay, so what we're going to do is go through this tutorial. Okay, so this Swift tutorial takes about 15 minutes. It gives you a quick tour of the Swift language. And basically what we want to do is go through the playgrounds. So we're going to start up Xcode 6, go to File, New File, and then create a new playground. Okay, so I'm going to do that. In the Git repository, you can find this playground already installed, okay, swifttutorial.playground, and then we're going to progressively do all three parts of this playground, and then develop an iOS application to do tip calculation, also part of this tutorial. And then finally we go over 2048, a tile game that you may have heard of and played. It's actually open source. You have the actual source code for it. It's very short, and you can compile it and run it in Swift so that you can get some idea of how it runs. Okay, so let's go to Xcode. We're going to do exactly what it says. We're going to open a new file. It's going to be a playgrounds file, and we're just going to dump it here. We're going to call it Swift tutorial live. Okay, and we're just going to hope everything runs properly while we're doing it. Okay, so this font looks a little big, but we'll see how well it goes. All right. So as I said, a playground is a new type of file that allows you to test out Swift code and see the results of each line in the sidebar. So we could add the following lines. So we're going to do exactly that. Okay, we're going to take these out. Okay, and you can see here that the read, evaluate, and print loop has already gone and done all of the calculations for this, right? Here, let tells you that these are constants, okay? So we're declaring a couple constants here, okay? But actually, we don't want to declare them as constants, right? So for example, if I say total team and I say plus equals 1, that's not going to work. Obviously, for a couple reasons. One is that this is a constant. Okay, so we want it to be changed to a variable. So there's a typo here. It says tutorial team. It should be total team. So we're going to change this to a variable. Okay, and then it works just fine. It becomes 80. Okay, and then that's all right. Okay, there's also explicit versus infer typing. So this is one of the features that Swift introduces, is that for certain things, it can infer the type. Okay, Swift is a strongly typed language, which means that each variable has to have a type. It cannot be sort of undefined. Okay, so for example, these two here are obviously integers. They can this can be inferred by the numbers that are after here. We can make this explicit, for example, by putting int after it. Okay, this explicitly says that this variable, or in this case, this is a constant. This constant is an integer, right? So we read the colon as sort of the type of this variable is int. Okay. All right. Floats and doubles and booleans and strings are very simple, right? So you can see all of these. I won't do them all. So if I, let's say, take this one, whoopee cushion, right, copy that and paste it, right, you can see the same thing. Because I've given a string on the right-hand side, it's quite clear that this constant should be a string, right, and not a float, for example. Okay. Then similar to what you might have seen in other languages, for example, in in Python, okay, you can do string interpolation. That's basically this bit here, okay, which means there's some escape, and then you're going into this part, right? There's this part here, and taking the expression that's within the parentheses, evaluating it, and then printing it out. Okay, so in this case, for example, name inferred has to be a string for it to be printed. Otherwise, there's a type error because print line only knows how to print strings. Okay, so we're just going to fix this up because we didn't actually do the Boolean part. That's why there's an error. So let's go ahead and put that in. Okay, and the same with the doubles here. Okay, and then this all works. All right, and again, you don't see the output here, but it's in the console output that I showed you before. It's in the assistant editor. Okay, so this is pretty simple. I think you guys all get this, right? It's an if statement. It has an else statement. All if and else control blocks in Swift, whether they are multiple lines or single lines, they need to be enclosed in braces. That makes the language very regular and very readable this way. Okay. Okay, now we're going to actually build the tip calculator. So at this point, we finished the first part of the tutorial. We want to now build a class, right? So classes are pretty easy. They look pretty standard as what you would think. So we have a class here. Okay, so we just declared a class. All right, and we're going to build a tip calculator based on that. So we're going to add some constants for the time being into the tip calculator. Okay. So we have a total, a tax percentage, and the subtotal. These are all of the double data type. Okay, and we're going to create an initializer for this class. That means when an instance of this class is created, what should be done, right? Okay, so we're going to do that. I just cut and paste here. All right, let's see what's going on. Oh, okay. So we need to give these things some information. We're going to do that soon. Okay. So we've created an initializer. You can see what it takes here. It takes two arguments, total and tax percentage. Okay. And it's going to set these two, right? Here is the argument to this function, right? So this total here and this total here is the same. And the ones referenced by self are the attributes of this class, right? Quite standard. I think you have seen this in Java before. Okay? So this means when you call the tip calculator, you must provide a total. That's the amount that someone is paying, and the tax percentage that's for that particular place. Maybe this would be more useful in the US where taxes vary per state. Okay? And then calculate a subtotal that is going to be calculated. Okay, so we have to prefix these two variables or these two constants here with the word self because, of course, there's two variables in scope that have the same name, right? So there's the total that refers to the argument of this function as well as total that refers to the argument of this class. Okay, so once we've done that, we're going to go ahead and add another function. Okay, here we are. Okay, so this calculates the tip with the tip percentage, right, which is the subtotal of the item, right, with the tip percentage. In the case of a pre-tip, meaning that you compute the tip before the tax was put onto the total. Okay. And then we're also going to create another function that indicates what type of tipping we might want to offer, let's say a waitress or someone serving us. Okay, so we might be less generous and tip 15% or very generous and tip 20%, or you can be measly and tip only 1% and change these values. Okay? All right, and at the end of the class, we're going to actually try it out, right? We want to run the class. So we have to create a tip instance, right? Okay, a tip calculator instance, and we're going to provide it with two arguments, right? The total, let's say I spent $33.25, and the tax percentage here, the GST, is 6% instead of 7, then I would get this. And then run tip calc to print the total possible tips, okay? And then I would get the output like so. Okay, so once we've done that, we'll get this file. This is stage 2, I think, already here. So if you go to the Git tutorial, it's this file over here. Okay, number 2. Okay, so let's see whether the assistant editor works. We'll just give it a shot. Hopefully it does. So I don't see it very easily. Okay, yeah, so you can see it there. All right, so we got output now. So this is the output from the bottom part, right? This is all the things that happened at the end of this statement. Okay, so you can see it here. All right, let's close this and shrink this again so we can see the tutorial as well. Okay, so we want to cover a couple other constructs, arrays and for loops. All right, so instead of having 3 lines of duplicate code, right, because this is basically calling the same function with different arguments, right? Why don't we use something like what we do in Python and call this function with an array, okay, where we provide each of the elements in turn. And we're going to use a for loop that looks very much like the Python one, right? So you can see it over here. We're going to first create 2 constants. Okay, so again, you can just see the typing here. We're going to get rid of this one. We don't need it because we only need 1. Okay, it's not actually broken into multiple lines here. It's just because the window on this computer is too small when I'm doing the webcast. Okay, so this is all 1 line. Okay, and then we're going to add these lines underneath. Right. So hopefully you can read what this is saying. Okay, basically we're saying we have an array. We can put whatever values we want here. Those are the tip percentages. Right now we have 3. We could add more, right? Like say, for example, I could add 10% tip or 5% tip, okay? And then I'm going to iterate through this array, right? I'm going to say for each possible tip that I have in this array, I'm just going to print the possible tip as a percentage, right? Because we've expressed it as a floating point. We're going to multiply it by 100 so that we get a percentage, and then call the function, right? Calc tip with tip percentage, and provide the argument that we have from possible tip, right? And then run that, evaluate it, and take the output of that and print it out. Okay, so we're going to print it out on the screen. Okay, and if we open the assistant editor, again, you should see pretty much the same thing as before. Once this runs, there are a little too many things happening on the computer, so we'll wait for a second here. Sorry. So I don't remember what I did. Okay, yeah, so you can see it here. We get a 10% as well. Okay? All right, so let's go back. Okay, there are a number of other ways that you can do a loop like this. So you can see here this version of it. So I'm going to blow it up here by putting it here instead, okay? So I'm going to comment this section out. Okay, and then paste this. Okay. And then basically what we have is a loop, again, going from 0 to the possible inferred tips count. Okay, in Swift, there's two different range operators, okay? Python has these things too. There's one with 2 dots and there's one with 3 dots, okay? The one with 2 dots is for the case where you use something like a count to find the number of items in a structure. So for example, you have an array, it has 10 items, you use the count method on it, it should return the number 10. Right? But you know that computer scientists, we don't like to count all the way up to 10. We'll count from 0 to 9, right? So when we do that, we'll have a problem if we use a standard range operator, which includes the last number inclusive, okay? So in Swift, they've added this double dot operator to omit the last fence post. This means that it'll go from 0 to 9, okay? But if you add the last one, it'll go from 0 to 10. Okay, including the last number, which sometimes will cause an error. Okay, so that's the difference between the 2 dot and the 3 dot syntax. Okay, so you can see that over here. This operator is a non-inclusive operator. It doesn't include the upper bound. There's also the triple dot operator, which is inclusive. Okay. So one last change you could do is, for example, to make it a dictionary. So instead of returning it as strings, what we can do is let the outside code deal with that. All right. So we're going to do that instead of printing it out in the function, right? So we don't want to call it print possible tips. Maybe we want to call it return possible tips instead. So we're going to comment all of this out. Okay. Okay, and the nice thing about the commenting syntax in Swift is it is nested. Okay, so for example, here I've opened up a multi-line comment. Okay, and I've closed it over here. Now, for example, if later on I decided, you know, for example, I want to comment out something else in the middle. Okay, this will still work. If you know in Java, for example, what the regular expression operator will do is it'll start saying, oh, there's a multi-line comment here. It'll keep on going all the way down until it sees the first version of a closed comment, right? And then it'll say the rest of this stuff down here is not a comment anymore. And then you get a syntax error. Okay, but why is this important? Because many times you want to comment out code, you might want to comment larger blocks of code out, and this syntax makes it very easy. So braces have to match, comment brackets also have to match. Okay, so this is a very nice technique that's going to make it much easier to debug once you get used to this syntax. Okay, so you can see now I've deleted it. I only have this part commented out. If I comment it again, then I'll have this all gone. Okay, so what I'm going to do is I'm going to cut and paste this again. Basically, I'm changing the function to return a dictionary, a hash table. All right, this hash table will have the key being the percentage that I want to tip, and the value being the tip amount. Okay, so I'm going to return a dictionary to the caller, and it's now the caller's responsibility to print things out. Okay, so I'm going to do that. Right, and here the tutorial is not quite right. So I think this particular tutorial was written for earlier version of Xcode beta 6. So we need to change a little bit of the syntax here. This is actually returning the dictionary, and the way we specify that is something like this. Okay. All right. The other version that's mentioned here is a shortcut syntax. It currently doesn't work. I spent a couple hours trying to figure that out. But anyways, this is the correct syntax for the current time, all right? Probably it will work in a couple weeks when Apple releases the next version of the beta, okay? So this is the normal version of how you would declare a dictionary, right? You have to give a dictionary. That's a data type, okay? And it's going to be a dictionary that has a tuple as an output, and an integer as a key, and a double as a value, okay? So that's exactly what we're going to do for both of these, okay? All right, so now we have return possible tips. That's great, all right? Now I need to actually do this function at the end, right? If I want it to run. So let's say we're going to go back here. This doesn't work anymore because, of course, I've commented out print possible types. Get rid of that, okay? and I'm going to put that in. That doesn't have any problems. And if we go back to the assistant editor, okay, wait. Okay, it eventually should say print this out. Okay, I think I forgot to print it. Okay, well, anyways, you would just do that. Okay, so this is the basics of the Swift language. All right, so for the second half, we're going to go over the development of an iOS application. All right, to also do tips. So we're going to use Swift code that we just developed for the second half. Okay, so we're going to save this live playground. Okay, and we're going to go on to the second part of this tutorial. Okay, so what we're going to do is we're going to actually have to take all of this code. All right, let's close this again. Okay, and create it into another file. All right, so what we're going to do is build a single view application, and we're just going to follow the instructions here. Okay, new project. All right. We're going to get a single view application. We're going to type next. We're going to give it a name, tip calculator 5. Okay, and we're just going to stick to Swift and make it for the iPhone, for example. Okay, and we're just going to, put it here. Okay, so now we have an application, and we can compile it. So we're going to compile it and run. Okay, we're going to make it for the iPhone 4S. Put. And looks like we didn't have any problems building it. And we're going to run the iOS simulator and wait for it patiently to come up. Okay, so this is our application. Congratulations, we have a working application. It does nothing except paint a white screen, so we're going to fix that now. Okay, but it is working. This is an iOS app now. Okay, so we'll quit the application and do something with this. So the first thing we need to do is, for example, take the Swift file that we created, okay, and then put it into our code, because it's going to form the basis of what we are going to do. All right. Now, some of you may not have developed any iPhone applications before and not done any software engineering project. So I need you to know that when you develop such applications, Apple follows the model view controller model, okay, of developing applications. Okay. So let's see whether we can understand what that means. If I can find the document. Okay, let's blow that up. Oops. I don't know whether I put it here. Okay. Okay, anyways, let's try finding it. Model view controller, Apple. I think I didn't put a link to it. Okay, so this is the basic idea of a model view controller. All right, this is Apple's version. Everyone has a slightly different take on it, and a lot of web applications work this way too. If you run Rails or Django in Python, you're also probably familiar with this. Okay, in Google App Engine, it has a version of this, right? You've seen views and controllers before, right? So the basic idea is the user interacts with the view. This is what people see, they interact with. For example, on an iOS device, that's the interface that they see, and they do some action like tap or swipe or things like that. That information is an event. It gets sent to a software component called a controller, so the controller decides what to do with it. For example, if there's some state about the application that needs to be updated, that usually is contained in the model. Okay, so the model is sort of like is all the database where everything is stored, all the information is stored. So when the user does an action, let's say types in a number, okay, for example a tip percentage, okay, then the controller has to go to the model and say, oh, the person typed in a new tip percentage, maybe you want to save that in the model somewhere if there's a database backing that information. Okay, the model updates its internal representation, sends that information back to the controller to say, actually, I saved that data, okay, you can do whatever you want with it, so that the controller then will say, okay, now that you've updated it, let me go calculate, display the new tip information, right, that the person has asked to calculate. So the controller will then pass that new tip information out to the view, and it'll be displayed on the screen. Okay, so the important parts are the view, okay, that's what the user sees, that's what the user interacts with, and the model, which is sort of like the state of the application, all of the data that it has, okay, and the controller is the important bridge between the two things that takes events that come in as a result of user actions, passes them to the model for the model to update itself, and for the model to then pass back some information, let's say a calculated value, for example, and then for the controller to tell the view, hey, this is the new value of this variable, go update yourself, paint the screen again, and show the user what happens. Okay? So a lot of web technologies use this software framework design pattern that's used in iOS and Mac design as well. Okay, so what do we see here? Basically, there's one thing that is built, okay, the view controller, all right, this is the controller that interfaces between the view as well as the model, okay. The storyboard here is the view, all right, this is what the user is going to see, and you can see it looks exactly like what we saw when we ran the iOS application, basically a blank screen, right. So that is the view, this is the controller. Where's the model? The model is what we built in the first part of the tutorial, and that's what we're going to put in now. Okay, so we're going to put in a new file. Okay, it's going to be a Swift file. It's not going to be a playground anymore, because we don't need it to be anything like that. We're going to call it tip calculator model, so that we know what it is, and then dump it in here. Okay, and we're just going to paste everything that we had before. Okay, so we don't need all of this tutorial stuff, right? We only need the class information, because the class is where we stored all the model, right? We needed to capture the total, the tax percentage, the subtotal, etc. Okay, and we don't need all of this stuff to actually run it, because now we're going to get input from the user. Okay, so we're going to delete that. So now we only have left the class. Okay, the class. All right, and then we can save that, and what we want to do is fix the class a little so it will actually run, because right now it's not going to compile. Okay, so we're going to close that. I'm going to go back here and shrink the screen again so that we can see what's going on. See what it will shrink more. Okay, well, all right. So we've done a couple things. We've opened the tip calculator, we've renamed the class, and we have to change a couple things. One thing that we have to change is the fact that these are no longer constants, because they're going to be provided values by the user, right? The user has to be able to say how much they spent, and they have to say how much the tax percentage is. So they obviously need to be variables, okay? And we're going to need to change the subtotal, but the subtotal is going to be calculated. It's going to be actually what they call a computed property, all right? So it needs to be set and gotten values from externally, okay? So we're going to follow this code over here to do that. Okay, that looks pretty messy, so I'm just going to indent it properly. So you can see this is actually a function within a function, right? So I've said this is a subtotal, but it gets its value by calling the function get, which is going to get the total and then all of this other stuff here, right? The tax percentage plus 1. So it's going to be calculated on the fly when something is set on this. Okay? So just like it says over here, a computed properly does not actually store a value. Instead, it's computed each time based on other values, right? Okay. And obviously, we don't need this statement anymore because it's going to be dynamically calculated whenever any of the two parent variables change. Okay. I'm going to save that. Okay. So let's see whether this runs. I have actually no idea what it will run. So it looks like it's running. Put, invoke. Yep. Okay. So we now have a model. We haven't connected any user interface to it, right? So let's do that next. Okay. So the next part is to build a user interface. Okay, this is something that other people who've done iOS development will be very familiar with. But basically what we're going to use is a tool that comes as part of the storyboard interface. Okay, it's called the Interface Builder, and it's part of the Xcode interface. All right, so we're going to go ahead and click on Main Storyboard, and we're going to look through the storyboard here. Okay, and I'm going to go through all of these parts. And pardon me, it's going to get really squeezy here. Okay, so here is the entire thing. Okay, we have here the interface builder. All right, there's the document tree on the left-hand side. Inside the interface builder, there's also another left menu that can tell you all of the different scenes or screens that the user interface is going to show. So, for example, if you have a game or a multiple window application, it's going to show them all here. Okay, right now we only have one screen. It's this blank screen. Okay, and we're going to do some things here. There are a number of inspectors that we're going to use for putting things correctly. And there's an object library we're going to drag widgets to construct the user interface from. Okay? All right. So the first thing we're going to do is follow the instructions in the code and create a navigation bar, navigation controller. So we're going to put that in. Okay, and what it's going to do is, if you zoom out, okay, you'll see that there's another view created that looks a little bit like an empty one, right? It's basically a view controller, and we have to decide what we want to put inside of this view controller, what the user is going to interact with. Okay, so we're going to go to the object library, which is this bottom right-hand corner, and we're going to put in a couple things. We're going to put in the label. Okay, put in a label, put in another label, put in a button, put in a text field, and put in a slider, and put in a text view on the bottom. Okay, and we're going to fix all of these up so that they're proper. Okay, I'm not going to do all of the geometry layout. You can look at the finished code, which is in Tip Calculator 2, if you want to see how it looks at the end. Okay, maybe I'll show you it later. Okay, so if you go back here, all right, what we want to do is do these steps here. Okay, we're going to build a user interface one part at a time. So we want to first take one of the labels and call it bill total. Okay, so we're going to take the next one and call it tax percentage. Okay, and obviously we want this to change, so we're going to connect that to an action later. Okay, we have a text field already. That's this one. We're going to ask a person to put in a number, so we want to change it to a certain type of keyboard type. For example, we don't want the default ASCII QWERTY keyboard, right? We want a decimal pad so that they can enter in a numeric value. Okay. Then the slider, maybe we want to change the minimum and maximum values. We don't want a tax percentage of just one, maybe up to 10%. And maybe we're going to fix it at a value of 6 to start with, because that's what we had earlier. Okay? And we're going to change this button to say calculate, because that's what we wanted to do. Okay? and we're going to take this and remove the default lorem ipsum text. Okay, so that's our user interface. The user is going to type in something over here for the amount, have a slider to indicate the tax percentage, calculate, and then in the text field at the bottom, we're going to display what we had calculated earlier in the print statements. Okay, that's all we're going to do. Okay, we're going to save this, and we're going to run. Hopefully that works. And hopefully you don't see the white screen of death. You'll see something that looks slightly more like an app. Okay, so there you go. Okay, I didn't quite fix all of the geometry, but never mind. We can do with that. So we'll just drag some of these over a bit more. Okay, so that they look a little easier to find. Okay, so we did all the values here. All right, I didn't set all of the geometry things, so you can do that yourself. We need to do a couple things to fix this. So the text view needs to be not editable and not selectable because we just want it to be displayed. Okay, and we need a tap gesture recognizer so that when somebody types in a value here and is finished, they need a way to get rid of the keyboard that we put on the screen. So we're going to do that. Let's see, where is it? Tap gesterizer, and we're going to put it here somewhere on the screen. Okay, so it's shown up. Okay, so we did this step, we ran it, we saw the basic user interface. Now we want to connect some things together. All right, so we're going to open up this the controller. Okay. And you can see it's a little bit different from what is indicated in the tutorial, and that's just because, again, things are still changing. But basically, this is the entry point to your application, right? Basically, this function is the initializer for your application. Did your application load properly? If it did, great, okay. You need to do any setup, then do it here, okay. If you have, if the device has very little memory left, for example, you're playing a couple games and doing a lot of multitasking, then this procedure will help to deallocate variables that are not needed to make the phone run faster. Okay. Hopefully, when you do software engineering well, you're going to actually specify something here. Okay. In any case, what we want to do is create some pieces of code that's going to connect what we have in our view, in our storyboard, to the controller, right? So that things actually happen when you touch things on the screen, right? So we're going to do that by pasting these properties into the view controller. So let's do that. Okay, so basically we're saying the interface builder, that's what these two letters mean, has an outlet, okay? And when the information comes from the view, the controller is going to receive it, right? So for example, there's a total text field. It has to have, it's of the type a user interface text field, etc. There's a user interface slider, a label, etc. And we're going to connect them together, all right? So we're going to go save this. We're going to go back to the storyboard. Okay, we're going to select each of these things. For example, this field is supposed to have the information about what to put in, right? So we're going to go to the last inspector. Where is it? Maybe I didn't finish this. Let's see. I think I'm skipping some steps. View controller. Yes, I did skip a step. Okay. We need to add these methods as well. These are the handlers that deal with this. This is just the variable, right? This is to receive the information, right? But we need code to actually do what we want to do, right? I forgot that. So here we are. These are stub codes, obviously. They don't do anything yet. So we have three functions. One is if you tap on the calculate button, or if you change the tax percentage, or if you tap the view anywhere on the screen. Okay, those are the three things that we want to respond to. Okay, we go back to the storyboard, and hopefully this is going to come up. I don't see it. Okay, did I miss out anything else? Okay, let's see whether it loaded correctly. I'm missing something. Ah, okay. Is this it? Okay. All right, so we're going to, let's see. Okay, so we define some outlets, okay, and we have to connect them to the application. So results text view, that's where we're going to display the results of our calculation. We're just going to take the circle that's over there and drag it to the text view. Okay, nothing else can work with this because it's of type text view. All right. Okay. Then we have the tax percentage label. All right, we're going to drag that to the tax percentage. The tax percent slider, we're going to connect that here. And the total text field, we're going to connect that there. Okay, so now these are linked to each other. Right? When we do something, it's going to invoke a function that is on our controller. Okay, so you can see what's going to happen here. Right? We're going to get these four things are going to be connected. Their variables are going to be connected to that information there. Okay. Okay, so you can read what it says here. Find the circle to the right of calculate tat. Drag a line from that circle up to the calculate button, which we just did. Okay. So we're going to do that. We haven't done that step yet. Sorry. Okay. So received actions. This was just to connect the widgets to their variables, right? Now we have to connect the actions to the things that are on the screen. So calculate tap. If someone taps the calculate button, I want something to happen. So for example, if they touched it, then it should run the calculate tapped function, right? If the tax percentage was changed, for example, this one over here, if the value was changed at all, I want the tax percentage change function to run. Okay. If the view was tapped, in general, let's see how we can do that. Okay, to the tap gesture recognizer, then I should run view tapped. Okay, those are the three functions that I defined in the view controller. Okay, you can see those three functions here. Now they all have this filled in circle to say that they've been connected with something. Okay. All right. Obviously, it doesn't do anything yet. So even if we run this code, it will look exactly the same as last time, right? You can run the slider, you can type things in, but you won't be able to dismiss the keyboard, for example, and nothing will change on the screen. So we have to do the last bit, which is to connect it together. Okay, and so that's connecting your view controller to your model. That's the final step, which is in the last part of the tip calculator tutorial, just part 3. Okay, so we have to first initialize the tip calculator. So we're going to create a model, an instance of the model. Okay, and also create a function to repaint the UI to make sure it's correct. Okay, so we're going to do that. Did I put it in the right place? See, add a property to your model on the ref. Connecting your view controller.swift. Oh, maybe, did I not add it? I thought I added it already. Well, it's there. It seems it can't resolve it, so I'm going to load from another stop point, which I had before. Okay, so this one has the actual geometries, right? Okay, so we had just connected the actions, we had connected the variable, so we're in the same place as before. Okay, and I'm going to try to do that last part again. Okay, so we connected the actions, and now we are putting in the functions to actually do the tasks, right? So we're going to put in the functions here that were used to be stubs, right? So let's go over these a little bit in particular, all right? So first, let's look at the tax percentage change, right? So what we're going to do with the tax percentage change is change the value back into a floating point because that's what we're storing in the model, okay? And then we're going to refresh the UI so to make sure it's working properly, right? So that's what we're going to do here. And view tat here says if you tap on the text field or anything, what we're going to do is go to the text field and turn off the keyboard. That's what this means, right? Because when you tap a text field, usually that means you want to put some input in, okay? So the default first responder, that means the element, the software element that responds to a tap on a text field is to pull up a keyboard, okay? So we want to get rid of that keyboard if someone taps on any other part of the screen, okay? So that's what this view tap part is doing, okay? So we coded those two things, all right? The last part is this function here, right? This is the heart of our function, right? It's to calculate. When the person hits the calculate button, what should they do? Well, I want to take some information from the text field, the total text field, which is a double value, and I'm going to cast it into something that I can use. So this syntax is just some typecasting between Objective-C and Swift. Okay, so I'm going to receive a double value in Swift, which is for my calculator. Okay, I'm going to go through the possible tips by asking the tip calculator to return the possible tips, right? This was the earlier part of the tutorial where we created a dictionary to hold all the key value pairs, right? So now this thing is a dictionary with keys that are integers and values that are doubles, okay? And then all we're going to do is for each of those things, just like we saw in the earlier part, okay, we're going to create a string called results, and we're going to just fill them in with the information, right? We're going to use the string interpolation to say how much percent, how much is the tip value, and then we're just going to set the text of the text view to this. Okay, simple enough. Okay, so let's see what it works. Yeah, the screen is a bit too small, so the keypad is off the screen. So let's type in some numbers here. 99.95, a popular price, right? Okay, and let's change it to the current GST in this country. Okay, and then we get the percentage, right? You can change it down. Let's imagine that GST was only 3%, then you would get a different value. Okay, so this is a basic iOS application. It's finished now. This is, of course, very simple. But basically, you get an idea of what's going on, right? So again, if you look at the information over here, you have a storyboard. This is you, okay? You have your controller. This is the bridge between the model and the view. And you have your model, right? This is storing all of the information about what's going on in your application, right? Usually it's represented as a single class which has some attributes that have some functions that modify or change it, right? So you can see our application is really simple. It just needs to store free values, right? That's what represents all of the information in our code, okay? So last thing I want to do with you before we finish this tutorial is have some fun, right? Okay, so have any of you played 2048? Yeah? You've probably tried it out before. Okay, we're going to run it. So it's really nice because it's open source. It's a game that very many people are familiar with, yet you can play it right here in your simulator, right? Okay, so this should look a little bit familiar, right? So you have to swipe down, right? Swipe across, swipe left. And your goal is to combine tiles until you get 2048. Yours truly has actually done that once. I'm not bragging or anything. Certainly not too hard to do. Okay, well anyways, you can change this code. All of the information is here on how to do it. Okay, so we're going to look at this code in a very short overview. Okay, so there's some code that you see is familiar with the previous version, right? The tip calculator. Namely, there's again a controller, right? A storyboard, that's the interface, and a number of files that are extra. Okay, this particular port of the Objective-C code, the original one, doesn't use the same interface builder. It builds the interface on its own. So the storyboard, if you look at it, looks pretty simple, right? There's no tiles, there's no anything. It's just a link to activate the game. Okay, so actually when you look at the view controller, you can see it's actually very simple. It doesn't do anything, right? Basically it says if you tap the start button, run another view. Okay, use the game controller called number tile game view controller, which is not obviously in this file, right? Because this is the whole file for the main controller. Okay, so actually these two files over here are doing almost no work. All right, they're just providing the hyperlink to start the game. Okay, the game is over here. Okay, so here's our model. Okay, if you actually look this up, you can see. Sorry, this is the controller, right? So this is the bridge between the two things. Obviously, the model is in the models folder, and the views are in the views folder. Wow, surprising, right? Okay, so you can look through all of these pieces of information here. Okay, so for example, the game model holds what happens when certain things are done. Okay, I think the controller does tell you quite a lot of information, so they commented fairly well. It says a view controller representing the 2048 game. It serves mostly to tie the model to the view, right? No surprise. Data flow works as follows. User input reaches the view controller and is forwarded to the model. So this code here hands the stuff over to these two files over here. Okay, to the two files over here. And then the moves are calculated by the model and then returned to the view controller and then forwarded to the game board view, which performs any animations to update its state. Okay, so I encourage you to look through all of this information. You know, how it does the views. This is, you know, if you think of it in web applications, this is the HTML and CSS portion of your application, right? How the thing looks like, right? So for example, what you have to do when the score changes, obviously you have to update the score. What's the background color of the fonts in the windows, etc. How does the game look when you slide things back and forth? What happens? Okay, so all of those things are here. Okay, the tile view. So where is the individual tiles, right? If I make a tile, what do I need to do? I need to create the background color for it. I have to create the text color for the label, and I have to set the value of the label to a certain number, right? So that's all this information here. Okay? Okay, so there's some homework associated with this if you'd like to try it. And that's the bottom part. Okay, so you can try filling out the file listing above, like over here, I've provided the files, and I've sort of explained what those things are, right? So the easy part of this assignment is tell me what they are, okay? If you can tell me what they are, post your answer to the reminder post in Mission Control, so so that everyone has a record of what these things are, okay? You can also style your tiles to be of a different color scheme, change the font to something else. That's really, really easy. So for example, if you look at the file, appearance provider basically is the CSS, all right? These are all the things about what color things are. So if you wanted to change the 2 to a different color, the green to a different color, you can see all of the upper level tiles, they're all the same color, some like dark yellow, okay? Okay, you can fix the code to implement to-do, okay, which is written in one of the files. At this point, we should stall the game until the user taps new game, which is after the game is over. For example, if you lose or if you get the 2048 tile, you have to restart the game. This isn't implemented in his code. It's very easy to do. You can go ahead and do that, okay? And some other ones that are easy and hard, right? You can change the game to 256 to make it easier, and you can change the game from another base. You know, instead of 2, make it 3, okay? Because 2 to the power 11 is 2048. 3 to the power 11 is 177147. Okay? That's a little harder because there's a lot of changes you need to make. Okay, any questions? I do want to go over a couple important points that you're going to see again when you take programming language class, okay? Which is about closures and generics. These are really easy to understand, actually. Okay, these are 2 features in Swift that are implemented in a lot of other languages, but not in C variants that are compiled. Okay, closures are a case where you have a function that returns another function, where the function inside needs access to information outside. So let's take a look at this, for example. All right. So I have an array here, okay, of strings, okay, and I want to create a function that returns the strings that are backwards, okay. Okay. So I'm going to create that function, and it's actually going to return these 2 strings, right, but reversed. Okay, so I can actually run that by providing the sort method, okay, a pointer to what is this function, right? This is a function. It's declared as a function, but it returns a Boolean value, okay? So then I'm actually creating another invocation of the inside function that has access to outside variables. Okay, it's actually used a lot in JavaScript and also in jQuery. The answer in Stack Overflow is a lot better than what I've just said, so I'll just skip to it, for example. Okay, so here I've defined a function within a function. The inner function gains access to all of the outer function's local variables. Okay. So when a function exits, all of its local variables are normally destroyed, right? You finish a function, you garbage collect everything, okay? But in the case of a closure, you keep them open so that you can have access to them later, okay? So anyways, you can read through this answer and try to understand it a little bit. Generics are a little bit easier to understand, okay? It's the case when you have multiple data types, okay, and you have some code that does almost the same thing, but for each data type. That's needed, for example, in strongly typed languages, right? Because every argument to a function must have a type, a data type, right? So you can't say call it on any type, okay? So in order to get around that, you have to have a generic. You say this is some type of object. Whatever works within this code works at the object level and doesn't inspect what happens inside of it, right? So in order for us to swap strings as well as swap integers or swap doubles, you can use this generic code to implement all of that instead of having 3 sets of codes to do the same thing. Okay, so that's all for this tutorial. I hope you had a chance to see what Swift is like, and do try it out. I think it's going to be a useful language, even outside of Apple's interpretation of it. Okay, thanks a lot for coming.